All right. So I'd like for you, before we use our calculator, to try this out. Plug in 3. Sorry, for the second equation. This is part 2 of our sequences and series patterns defined. Go ahead and solve that to the right. See if you can get the series value. All right. For your value, you should have gotten 90, but let's check with our calculator what we're able to do. So if we turn our calculator on and we go to math, we go over to, wait a minute. Sorry, it's on the math. If we go down to summation, press enter. Oh, look at that. It's exactly what we have there. So if we're going to do that one, we're starting at 3. So you have to define it as x or theta or whatever. I think I'm in, why am I in? Let's get out of that. Okay, go back to my home screen. I have theta still. Why did it? Okay, whatever. 3 up until 6. I think you guys probably can't see this, but just bear with me. It says 3 to 6 plus 1 plus x squared. Where's the squared? I'm going to go back here because I'm worried it's not going to work because I have a theta there. There we go. If you press enter, you get 90. It immediately does your summation. All right? Pretty cool. 90. Done. All right. The last thing that we're going to talk about is factorials. A factorial is not a loud number like 0 or 1 or 6 or negative, whatever. So what it represents, it's used in probability. And for instance, if we took our class of 26 students and we said, hey, how many ways can Mr. Fincher create a seating chart? And that would be 26 factorial, which means that I can have everybody sitting in the same spot except for one person switch. And then actually one person stay in the same place and everybody switch to all the possibilities and then do that for every single student. There are so many ways. If you put this in your calculator, it's going to be way more. So Mr. Fincher has many options to what he could do as far as his seating chart. Oops. 26. If you press math and go over to probability and to the big exclamation point, we have that many possibilities. So that's 4.03 and more numbers. And that means that you have to move that decimal place 26 to the right. So I'm not going to that's not possible for us to do. But that's what a factorial is. Factorial is actually, if you do, it says at the top, oops. It's basically the number that's next to it times every number below it until you get to 1. So 6 factorial is written as 6 times 5 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. Now, what's great about this is we do have some cancellation occurring. 3 and 3 cancel, 2 and 2 cancel, 1 and 1 cancel. So our final answer is what? It's 30. Awesome. What about 12 factorial, 6 factorial, and 8 factorial? So 12 factorial is 12 times 11 times 10 times 9, all the way until we get to times 3 times 2 times 1. 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. And then we have 8 times 7 times 6, 5, 4, 3. That's crazy. As far as canceling things out, which one would cancel out more? 8 factorial cancels every number all the way through here. So I'm going to go ahead and cancel this guy out. And that makes it simplified to 12, 11 times 10 times 9 over, and we'll just keep this as 6 factorial. I don't think much will change. You could maybe divide out something, but we're not going to stress about that right now. That would be how we would simplify that first step. But what if, so I want you to go ahead and try this out. 5 factorial and then 2 factorial. Actually, let's do it like we're generalizing it like with n equaling 5. So remember, 5 would be 5. That we'll pretend like that's 5. How do we get 4? That would be n minus 1. How do we get 3? N minus 2. We get 2 n minus 3. And how do we get 1? That's n minus 4. And then we don't go any further. Does that kind of make sense? So like if this were 5, then this is the expression for 4, 3, 2, 1. Now for 2 factorial, that would just be, well, that would be these two guys, right? So, because we already said that was 2 and that was 1. So remember, let me write that in a different color. So this represents 5, this is 4, this is 3, this is 2, this is 1, this is 2, this is 1. So to cancel, we would normally cancel the 2's and the 1's, but here we're canceling these two expressions, so we end up with that. Let's simplify 3 factorial in the same idea, but now we're going to generalize n equals 3. So for n equals 3, we have n minus 1, so that would be 2. This is 3, this is 2. If I want 1, that would be n minus 2. 6. Ugh. How much do we have to add to 6? To get 6 from 3. So that would be adding 3, adding 2, adding 1, just n minus 1, n minus 2. So remember, this is 6, 5, 4, 3, 2, 1. And we have 3's cancel, 2's cancel, 1 cancels. Sorry, it's not in red. It should be in red. Boom, boom, boom. And so we have that as our final answer. Now, all of this is to show you that if I start with something that looks crazy like this, n plus 2 quantity factorial over n factorial, we can cancel things out, even if they do seem to go in forever. So the way you'd write this, I need to get out of red. So that would be n plus 2. If I take away 1, that would be how I get to the next one. So n plus 1, take away 1 again, I get n, take away, wait a minute. The rest of that is n factorial. And I have n factorial down below. I do not need to go any further because these will cancel. Whoa, I don't know what happened there. It's pretty wild. So my final answer is, when I'm in, oh yeah, I am in red. I'm going to make that an n squared plus 3, n plus 2. Easy enough. That's really what I'm going to ask you to do. This last slide was supposed to lead you to it. I don't want you to stress about doing what we did on this slide particularly. I do want to make sure that you got this down, simplifying a factorial. Now I'd like for you to pause the video and try this one on your own. Okay. So we start with the top, n plus 2, n plus 1, n minus 1, and then that's where I can do my factorial because it matches the denominator. And so I have this cancels this. Done. Try this one on your own. Pause the video. All right. Which one should I start with? I probably should start with the bottom because I'm not going to ever get to the bottom unless because the top is the smaller term. So n minus 1, I'm going to stay as that. For n factorial, I'm going to do n minus 1. Oh, now they match. So cancel and cancel. And so my final answer is 1 over n. All right, for the rest of class, you have a beautiful worksheet that is posted online. You can go ahead and get started on today's date and enjoy. This is some great stuff. Have a great day.